Alrighty, y'all. So like I said, 8.4, and this deals with theorems about zeros. All right, y'all. So this first example, they're going to give me zeros, and they want me to find the polynomial that produced those type of zeros. So I'm going to write out the steps as I go through this problem, because what we're doing, since they're giving us the zeros, we're going to be working these in reverse from what we did last week. So for this example, they want me to find the polynomial of degree 3 that has the given zeros. All right, all the zeros are giving me are -1, 2, and -9. All right, so before I start, I'm going to explain right here. They want a polynomial degree 3. What that means when I'm done, the highest exponent for the polynomial I come up with has to be a 3, okay? So that's got to be my highest exponent. Now, since they're giving me zeros, remember zeros and solutions are basically the same thing. So the first thing I'm going to do is write these out using the x as my variable. So since it's 0 and -1, that means x equals -1. A 0 or 2 means that x equals 2. And a 0 or -9 means x equals -9. So we're basically going to work in reverse. So the first step I'm going to do, I need a 0 on the right side of each equation. So I'm going to get a 0 on the right side of each equation. So to get a 0 on the right side, I'm going to add or subtract and move them numbers to the other side with the x. So since that's a -1, to make that a 0, I'm going to add 1 to both sides. And that'll give me x plus 1 on the left side equal to 0. All right, this one's a 2, so I'm going to subtract 2 from both sides. And that'll give me x minus 2 equals 0. And then, y'all, the last one, since that's -9, we're going to add 9 to both sides. And that'll give me x plus 9 equals 0. So now, using the zero product rule, since I got 3 equations equal to 0, I'm going to put the left side of each equation in parentheses and set the entire thing equal to 0. Okay? So this is sort of going in reverse of what we did last week. Last week we started with parentheses and we had to come up with the zeros. So we're going in reverse. So that means step 2, and I call each of these a binomial because they're 2 terms. So I'm going to put each binomial into parentheses and set equal to 0. All right, now here's the fun part. At this point, I got 3 sets of parentheses being multiplied. So I'm going to multiply until done. So I'm going to start with two of these at a time. So y'all, first of all, I'm going to take these two sets and FOIL them together. So I'm going to bring down the x plus 1 for the moment. And what we get from this when we FOIL it, we'll put into our parentheses. So y'all, let's do that on the side here. So I'm going to multiply the x minus 2 times the x plus 9. So once we FOIL this, we're going to put our answer into parentheses, okay? All right, y'all. X times x is x squared. X times 9 is 9x. Now we're going to distribute that negative 2. So negative 2 times x is negative 2x. Negative 2 times 9 is negative 18. And y'all, the last step is to add the like terms. So I get an x squared. 9 minus 2 give me 7x. And then minus 18. So I'm putting that into parentheses now. X squared plus 7x minus 18. And all of this is still equal to 0. So y'all, I did that. And we put that right there. So now we're going to multiply. But y'all, now we got two things times 3. So I'll just keep that going right here. Since that'll be my last step is multiplying this. So you got two things here times 3. So we're going to get 6 terms, okay? So the x times x squared is the x cubed. X times 7x is a positive 7x squared. So remember, I'm just adding exponents. And this x technically has a 1. And that x has a 1. So 1 plus 2 gave me 3. 1 plus 1 gave me 2 x's. Now that x times negative 18 is a negative 18x. All right, now I'm going to distribute the 1 times x squared is 1x squared. 1 times 7x is 7x. 1 times negative 18 is a negative 18. All right, so now let's add the like terms. So bring down your x cubed. So the x squareds are like terms. So 7 and 1 give you 8 x squareds. The x's are like terms. So you got negative 18 and 7. So that'll give you negative 11x. And y'all at the end is our negative 18, all equal to 0. So now we've got our polynomial. The highest exponent is 3. And y'all, that's what they were telling us right here. It has to be a degree 3. So in MATLAB, once you got the polynomial equal to 0 and you've multiplied everything, that now becomes my function. So f of x equals x cubed plus 8x squared minus 11x minus 18. And y'all, on this first one, MATLAB gives you everything for this answer other than that one number that's in front of the x squared. So to finish this problem in MATLAB, all we had to do was put that 8 in the box. Okay, MATLAB gave you everything else. And you'll see that it should match up with what we had, okay? All right, so that's doing 3 integer type numbers. So next, we'll do the same type problem, but they're going to throw some imaginary numbers at us, okay? All right, so for this example, we're going to find a polynomial. with zeros of 5, 7i, and a negative 7i. All right, also, my first step, once again, they're giving me 3 zeros. Those are my 3 solutions. So I'm going to come over here and put x equals 5, x equals 7i, and then x equals that negative 7i. All right, also doing the same thing. We're going to get zeros on the right side. So add and subtract as needed to get zeros on the right side. So for this one, we're going to subtract 5 from both sides. And y'all, that gives us x minus 5 equal to 0. All right, this one's a positive 7i, so we're going to subtract 7i. And I get x minus 7i equals 0. And then this is a negative 7i, so I'm going to add 7i to both sides. And y'all, that one will give me what? An x plus 7i equals 0. All right, now since I got zeros on the right side, I'm going to put all these binomials inside the parentheses. X minus 5 times x minus 7i times x plus 7i, and set all them equal to 0. All righty. When you got imaginary zeros like this, that's the first thing you want to multiply no matter what. So I'm going to FOIL those first. And y'all, let me give you a little story about these. So I got an x minus 7i times an x plus 7i. When you got two binomials that match other than the subtracting and adding, we call this conjugate pairs. So these are conjugate pairs. And what's nice, when you FOIL conjugate pairs of imaginary numbers like this, the I will disappear. Okay? Now, what's going to help us in doing this problem is you need to recall one thing. When you get an I squared, and y'all, let me pull that calculator up and show you this. So I'm going to pull up my calculator, and I'm going to show you what I squared equals. Now, to get the I, you hit the second blue button and the decimal. You'll see a little blue I above that. So hit the second button in the decimal, and then I'm going to square that. So this would be like an I times I, which is the I squared. And y'all, when I hit enter, oh, let me get my mode back real quick. I don't want all that other stuff. All right, now when I hit enter, y'all, let me go back one more time. And I'm going to do I squared. Well, I don't know why it's putting that 0y. I guess because I'm multiplying i's. But really, this is -1 because 0i means 0 for that part, okay? I guess they're just putting it in that a plus bi form. So anytime I get an I squared, I'm going to replace that with a -1, okay? All right, I'm just looking at one thing on this calculator real quick. Oh, I know why it's probably doing it. Let me go to classic mode. So second decimal, square that, and still putting that 0 on it. My old calculator don't do that, so the CEs must be doing that, okay? But y'all, the gist of it is, when I get an I squared, I'm going to replace it with a -1, okay? All right, y'all, so let's FOIL this, and I'm going to show you how the imaginary part goes away. X times X is X squared. X times 7i is a positive 7ix. Negative 7i times x is a negative 7ix. And y'all, that negative 7i times 7i is a negative 49i squared. All right, so anytime you FOIL conjugate pairs, whether they're real or imaginary, your middle two terms are going to cancel every time. All right, so I'm wondering what's going to happen here. I'm going to bring down that x squared. And y'all, I'm going to bring up the chat. And let me ask y'all this. What is this negative 49i squared going to equal? Because y'all remember, I squared we said equaled what? -1? So that's like a negative 49 times a -1, which is going to make that a positive 49. Anytime you FOIL conjugate pairs of imaginary numbers, it's going to come up plus in the middle, okay? All righty, so what that does, I'm going to bring down this x minus 5. This, when I FOILed it, gave me x squared plus 49. And all that equal to 0. So y'all, I'm just going to bring that over to where I brought it over. All right, so now 2 things times 2, we're going to FOIL this. Now I had 3 zeros, so once again, my highest exponent has to be a 3. Okay, your highest exponent cannot be higher than the number of zeros you got. All right, also, x times x squared, 1 plus 2 gives me x cubed. X times 49 is a 49x. Negative 5 times x squared is a negative 5x squared. And then negative 5 times 49 is a negative 2. What's that? 45? All equal to 0. So y'all, let me ask y'all, I got one more thing I really need to do to this. And that would be to put this thing in descending order from my highest exponent to the next exponent to the next exponent, then the number. So putting it in order, I get an x cubed minus the 5x squared plus the 49x minus 245 equal to 0. All right, y'all, then the last step, write it as the function. And the function is going to be the same as I got here. X cubed minus 5x squared plus 49x minus 245. Now, y'all, this one, you had to put in the numbers in front of the variables and then at the end. But notice, they've already got the minus and pluses. All you had to do for this problem is put in those 3 numbers, okay? All right, y'all, so I'm going to do another one like this. So the first four problems in your homework is nothing but foiling, okay? All right, so let me get this paper ready. All right, y'all. So the next example, find a polynomial lowest degree. With zeros of. All right, so my zeros are square root of 2, negative square root of 2, and 4. So this time I'm getting radicals. The last one I had imaginary numbers. But notice, these are also in conjugate pairs because you got one plus and one minus. And y'all, the reason you're getting two of these is because remember when we took square roots, we always put a plus or minus in front of them square roots, right? So that gave you the positive and the negative. All right, y'all, so three zeros, three equations. X equals square root of 2, x equals negative square root of 2, x equals 4. Hey, but y'all, the steps are going to be the same. I'm going to get a 0 on the right side by adding and subtracting. So if it's positive, I'll subtract. So I get x minus square root of 2 equals 0. That one's negative, so I'll add a positive square root of 2 and get x plus the square root of 2 equals 0. And y'all hear that's positive, so I'll subtract and get x minus 4 equal to 0. All right, so I got them everything set to 0. I'm going to put all these in parentheses now. X minus square root of 2, x plus square root of 2 times x minus 4 all equals 0. So, do you notice these square roots are going to be the first thing I'm going to FOIL because these are conjugate pairs. Now, what's nice about FOILing conjugate pairs of radicals? The radicals will disappear. Just like on the imaginary stuff disappeared, okay? So x minus square root of 2 times the x plus square root of 2. Now, y'all, here's something you need to recall for this problem. A square root times itself. So a square root of a times square root of a equals a. So no matter what number you put in here in place of that a, when you multiply them together, you get that number, okay? All right, y'all, so let's FOIL. X times x is x squared. X times square root of 2 is a square root of 2 times x. Negative square root of 2 times x is a negative square root of 2 times x. Notice, I'm not putting that x up under that radical. Numbers inside a radical can only multiply by numbers inside the radical, okay? So you got to keep the x's to the outside. Now here, a negative square root of 2 times a positive square root of 2 is a negative square root of 4. But y'all, in a second, we'll take the square root of that and it'll come out as a number. Right here, square root of 2, negative square root of 2, these cancel. So remember a while ago I said anytime you multiply conjugate pairs, the two middle terms are going to cancel every time. So I bring down that x squared minus the square root of 4. Well, y'all remember the square root of 4 is 2. So if you're using this property, square root of 2 times square root of 2 equals 2, which is what we got. So put that in the first parentheses, x squared minus 2. Multiply that by the x minus 4 now, and we'll set that equal to 0. So y'all, this came over to there. So now we got two things times 2. We're going to FOIL again. So y'all, a lot of foiling on tonight's homework, okay? All right, let's see what we got. X squared times x is an x cubed. X squared times negative 4 is a negative 4x squared. Then I got negative 2 times x is a negative 2x. Negative 2 times negative 4 is a positive 8. All equal to 0. All right, y'all, look here. No like terms on this one. So my final answer is f of x will equal x cubed minus 4x squared minus 2x plus 8. So on this one, they had a B, C, D multiple choice answer, okay? Alrighty, so any questions on them three so far? So y'all, number 4 is going to be similar but different. They're going to use different terminology, okay? All right, so this is going to be like your number 4. We're going to find a polynomial degree 4. So that means the highest exponent on this one will be a 4. With the following. All right. Negative 3 is 0 of multiplicity 3. Zero is a 0 of multiplicity 1. So y'all remember, this multiplicity, that's telling you how many times these zeros are occurring. So this negative 3 is a 0 3 times. And then 0 is a 0 1 time. So I got x equals negative 3 times. And then x equals 0 1 time. So it's a degree 4. You got to have 4 zeros, okay? All right, now it becomes the problem we've been doing. Add 3 on these first 3. But y'all, that one's already solved for 0. So we just got to fix these 3. And since they're the same, each one of these will add 3. So that we get x plus 3 equals 0. And y'all, like I said, this one's already done. Now, this one I'm not putting in parentheses because it's not a binomial like these ones. So this one, I'm just going to put the x in the very front. Sort of like those problems looked last week when we had to do the zeros and multiplicity. And then the x plus 3's, I'm going to put them in parentheses, each one of them. So if you got single variables, they don't want to go inside the parentheses. We'll just pile them up out front, okay? All right, so what I do on these ones, I'm going to start by foiling the last 2. So this x and this x plus 3 will come down. And we'll foil this on the side to see what goes here. All right, y'all. So x plus 3 times x plus 3. Now, these are not conjugate pairs because there's not one of these that shows subtraction. So they're both being added. So these are not conjugate pairs, okay? All right, y'all. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Add the like terms, and we get an x squared. 3 plus 3 is 6x plus or 9. So that'll go into these parentheses. And all this equal to 0. All right, so next, I'm going to multiply this. So I'm really not fooling it because I got two things and 3, okay? So I'm just going to multiply them on the side here. X plus 3 times x squared plus 6x plus 9. All right, y'all, so here we go. Multiply the x by all three of these. X times x squared is an x cubed. X times 6x is a 6x squared. X times 9 is 9x. So when you multiply by x, you just added 1x to everybody. Now we're multiplying everybody by 3 over here. So 3 times x squared is 3x squared. 3 times 6x is 18x. 3 times 9 is 27. All right, y'all, so let's see. We got some like terms here, so I'll bring down your x cubed. The x squareds are like terms. So 6 and 3 give me 9x squared. The 9x and the 18x are like terms. So that gives us 27x. And y'all at the end, bring down our 27. So this x comes down. And when I multiplied these two, I got this. X cubed plus 9x squared plus 27x plus 27. So remember, when I'm done, I got to have a degree 4, so my highest exponent's a 4. So y'all, we're on the way because I got a cube here. And now, this x out front, we're going to distribute times all 4 of these. So x times x cubed is an x to the 4th. X times 9x squared is a positive 9x cubed. X times 27x is a positive 27x squared. And then x times 27 is 27x. And y'all, all these are still equal to 0. So y'all, the last step is to put it in function form. So x to the 4th plus 9x cubed plus 27x squared plus 27x. So on MathLab, you had to actually write this one all the way out. All right, y'all, so don't worry, it tones down a little bit after this one, okay? So the next 3 problems are not going to be bad. Now, y'all, so let's look at what we call properties of zeros. So properties of zeros. And y'all, there's just 2 properties that we're looking at right here. The first one deals with imaginary zeros. Remember, imaginary zeros are the I, okay? So the thing about imaginary zeros is they always come in conjugate pairs. Okay, so they always come in conjugate pairs. So what that means is if uh, if 8i is a zero, then negative 8i must be a zero also. Okay, so they got to come in conjugate pairs. That's because to get these type of answers, you did square roots of negative numbers to produce imaginary. And in front of the square roots, we always put a plus or minus, remember. Now, they could look like this. If something like this, 3 minus uh, 2y, if that is a zero, then 3 plus 2y must be a zero also. Okay, so don't change the number, only the imaginary part changes, okay? All right, also, the second property deals with the radical zeros. Those are your square roots. And guess what? They always come in conjugate pairs just like imaginary. So always come in conjugate pairs. And I'll show you examples of those. If a square root of 7 is a zero, then negative square root of 7 must be zero also. And y'all, sometimes those could even look different. I could have something like 5 minus square root of 2. So if a 5 minus square root of 2 is a zero, then 5 plus square root of 2 must be a zero also. Notice the 5 didn't change, just the stuff in front of the square root, okay? So 5, 6, and 7 deal with that. So this would be like 5. Suppose a degree 4 polynomial has some zeros of let's see, they're giving me a negative 2, a square root of 5, and a 9/5. So degree 4 has 4 zeros. They gave me 3 of them. So we want to know what is the other zero. Y'all have any guesses on that? What could be my other zero if they gave me these 3 right here? And y'all, really only one of these we even talked about up here, right? That's going to be that square root of 5. So if a square root of 5 is a zero, the other zero is a negative square root of 5. Hey, y'all, so that's all we're doing, using these 2 properties to come up with these other zeros, okay? So this one's the same thing. Suppose degree 4 polynomial has some zeros of a negative I and 2 minus the square root of 7. What are the other zeros? So y'all, on this one, you need 4 zeros. They gave me 2 of them. So I need to come up with the other 2. So y'all, the other zeros will be the conjugate pair of a negative I, which is a positive I, and the conjugate pair to a 2 minus square root of 7 will be 2 plus square root of 7. So 5, 6, and 7 I'm not doing because 7 is just like this one pretty much. That's all you're doing is you're finding what zeros are missing based on what they're giving you, okay? So y'all, guess what? More foiling coming up on 8 and 9. This was just to get you ready for number 8 and 9, okay? So let's see how we do on those. So for this example, we're going to find a polynomial of lowest degree. So they're not telling me what my exponent will be this time. That has some zeros of negative 4i and 2. So that's what they're giving me. They want me to find the polynomial, so that means I need to come up with a function when I'm done. But y'all, guess what? Right off the bat, they're giving me 2 zeros, but we really have 3 zeros. Okay? Because if negative 4i is a 0, positive 4i must also be a 0. Because those come in conjugate pairs. So my zeros are negative 4i, 4i, and 2. So I'm going to set them up. X equals negative 4i. X equals a positive 4i. And x equals 2. And y'all, this one's like number 8 right here, okay? That's why they did the problems like number 5, 6, and 7. They wanted to realize that if they gave you anything imaginary, then its conjugate also has to be a 0, okay? All right, y'all, I'm going to work these like I did the first 4. I need a 0 on the right side. So here we're going to add 4i. And y'all, that gives us x plus 4i equals 0. Second one, I'm going to subtract that 4i. And I get x minus 4i equals 0. And y'all, the last one, I'm going to subtract 2. And I get x minus 2 equals 0. All right, I'm going to put them all in parentheses. All equal to 0. All right, y'all, so remember, if you got imaginary, that's the first things you want to FOIL so we can get rid of this imaginary stuff, okay? So I'm going to do the x plus 4i times x minus 4i. Remember, these are conjugate pairs. One's added, one's subtracted. So that means the I will disappear. So y'all, x times x is x squared. X times negative 4i is a negative 4i x. 4i times x is a positive 4i x. And then 4i times negative 4i is a negative 16i squared. So y'all notice the middles cancel. So bring down that x squared. And y'all, what did we say I squared equaled? I squared always equals -1. And the only purpose of that I squared is to turn this negative number positive. Because now I got a -16 times -1, which gives me a positive 16. So that's going in the first parentheses, x squared plus 16. And then bring down to x minus 2. So that went right there. And y'all look at this, 2 things times 2 again. So now we foiled those. So y'all, most of these problems, I'm not going to lie, they got about 2 or 3 times that you got a foil on them, okay? All right, y'all, here we go. X squared times x is x cubed. X squared times -2 is a -2x squared. 16 times x is a 16x. 16 times -2 is a -32. All right, so my last step, MATLAB's going to give me f of x equals, I need to put in my function, x cubed minus 2x squared plus 16x minus 32. So y'all, that right there is what MATLAB is looking for, okay? All right, y'all, so number 9 is just like this one. All right, let me get my paper fixed. Yeah, y'all, let me see here. So, like I said, this will be like number 9. Find the polynomial lowest degree. That has some zeros of a square root of 3 and a 2i. All right, y'all, what that means, since they're giving me a square root of 3, that means negative square root of 3, and they gave me a 2i, so that means a negative 2i. Both of these must also be zeros. Okay, both of these have conjugate pairs, and that's what they are. So we're going to start out x equals square root of 3, x equals negative square root of 3. So I'm going to put my radicals together, then my imaginary. So x equals 2i, x equals negative 2i. So I got 4 zeros. So y'all, when we're done, my highest exponent has to be 4. All right, so I'm going to move everything to the other side. So I get an x minus square root of 3 equals 0. I'm going to add square root of 3. So I get x plus square root of 3 equals 0. On this one, I'll subtract 2i. So x minus 2i equals 0. And y'all, finally will add 2i and get x plus 2i equals 0. All right, so all 4 of these can now go in parentheses. And set everything equal to 0. So y'all, I can do 2 things at once here. So first, I'm going to foil these 2 together, because they're conjugate pairs, but I'm also going to FOIL these two together because they're conjugate pairs. So y'all on the side, I'm going to start out with this one. X minus square root of 3, x plus square root of 3. We'll figure this out, put that here, and then we'll figure these two out, put that next. Y'all, so let me show you a trick. Since these are conjugate pairs, you can shortcut. You don't have to FOIL the whole thing out because the middle and the outer always cancel. So the shortcut is x times x, which will give you x squared. And then the last two get multiplied. So that'll be x squared minus square root of 9, which y'all gives me x squared minus 3. Remember, square root of 3 times square root of 3 equals 3. And anytime you do radicals, they end up negative, okay? So the first two gave me x squared minus 3. Now let's FOIL this. X minus 2i, x plus 2i. Now, y'all, you'd have got the same thing if you FOILed this all the way out. But, y'all, like I said, the negative square root of 3x and the square root of 3x, they're going to cancel every time. Just like this one, I can shortcut in. X times x is x squared. Negative 2y times 2y is a negative 4i squared. But y'all remember, I squared equals negative 1. So that ends up being an x squared plus 4. Imaginary always end up positive in the middle. And y'all, all this equal to 0. So I had to FOIL once, twice. Now I got to FOIL these two together. But I'm happy I don't have any radicals or any imaginary left, okay? All right, so here we go. X squared times x squared is x to the 4th. X squared times 4 is a 4x squared. Negative 3 times x squared is a negative 3x squared. And then that negative 3 times 4 is a negative 12, all equal to 0. All right, y'all, we got like terms on this one, so bring down the x4. 4 minus 3 leave me 1x squared, and then bring down my negative 12. All right, y'all, so the last thing would be what? Put f of x here and write our function, x to the 4th plus our x squared minus 12. And that right there is what MATLAB wants you to put in that box. All right, y'all, so I will say foiling's over for now. And 10 and 11 are doing something a little bit different, okay? So let me show you what we're going to do here. So 10 and 11, we're actually going to be given zeros, and we're going to find all the rest of them. So they'll say the polynomial has the given 0, and then find the other zeros. All right, y'all, so they're giving me my function, f of x equals x to the 3rd plus 2x squared minus 3x minus 6, and then I got a semicolon, and they're giving me a negative 2. So they're telling me negative 2 is my first zero. I got to find, since that's an x to the third, I got 3 zeros altogether. So I got to find the other 2. And y'all, the way that we do that is by synthetic division. So I'm going to write out the coefficients of my function. 1, 2, negative 3, negative 6. And remember, we came down and drew a line under that, leave some space, and box under the last number. And the first number they gave me for my zero was negative 2. So y'all, since negative 2 is a zero, when we're done doing synthetic division, we better get a zero here, okay? And then these numbers over here will be the coefficients of the new polynomial. So let's get this done first. So synthetic division, you brought the first number down. And then 1 times negative 2 was negative 2. 2 and negative 2, you added and got 0. 0 times negative 2 is 0. Negative 3 plus 0 is negative 3. And then negative 3 times negative 2 is a positive 6. And y'all right there, I get a 0 remainder. So these are the coefficients of the new polynomial we're going to check. And it always starts out 1 degree less than the original. Okay? So these are the coefficients of the new polynomial. Okay? And like I said, it always starts out 1 degree less than this one. So that means this would be 1x squared, 0 x's, and then minus 3. And guess what? Once we get our new polynomial, we're going to set it equal to 0. Now, since this is the x squared, I can solve this using my quadratic stuff. So this, we're going to solve the quadratic equation. So once you get it down to an x squared, we can do the quadratic stuff, okay? So you can factor it to solve it, use the quadratic formula, or since I don't have an x term, anytime the x term is 0, I can do the square root stuff. So I'm going to solve this one by doing the square root. And remember, I'm going to add 3 to both sides. So I get x squared equals 3. And remember, at this point, since that's the x squared, I'm going to take the square root of both sides. Since I'm taking the square root of a number, I'm going to put a plus or minus in front of it. So y'all, square root of x squared is x. And that's going to equal a plus or minus. And y'all, this is not a perfect square, so we cannot simplify it. So that's just going to give me a plus or minus square root of 3. So for this problem, the other zeros are a square root of 3 and a negative square root of 3. So anytime we get down to an x squared being our highest exponent, we're going to do the quadratic stuff. All right, y'all. Now, I don't put the negative 2 because they gave me that one. Remember, there's 3 altogether. They gave me 1, so I came up with the other 2. All right, y'all. So number 11 is going to be just like that. So this one will be like number 11. So for the polynomial, 1, 0 is given. find the remaining zeros. All right, y'all, so they're giving me P of X equals X to the fourth plus 16X squared minus 225. And they're telling me 5I is a zero. So y'all, this is going to give us a little bit of stuff we got to do to this one. Notice I got an x4. I don't have an x3 term. I got an x squared. I don't have an x term. And then I got a number at the end. So I need to use zeros on this one for the missing terms. So use zeros as placeholders for the missing terms. See, this is the first one y'all have encountered where you didn't have all the terms in descending order. You got an x4 term, its coefficient is a 1. But y'all, we don't have a 0x cubed up here, or we don't have an x cubed term, so that's like a 0x cubed. We got the x squared term, so that's a 16. We don't have the x term in here, so that's another 0. And then at the end is a negative 225. And y'all remember, anytime you're missing exponent terms here, you got to put 0 in for their place. All right, draw my line. We'll box under the last one. And they're telling me to start with a 5I. Look, also, let's watch this one. Bring that 1 down. 1 times 5I is 5I. 0 plus 5I is 5I. Now here's where the I squared stuff will come in. 5I times 5I. So do y'all want to guess what that equals? 5I times 5I. So that is a 25I squared. But y'all remember, I squared equaled negative 1. So that means 5I times 5I is going to give me a negative 25. All righty. 16 and negative 25 give me negative 9. Negative 9 times 5I is a negative 45I. 0 and negative 45I is a negative 45I. And y'all look here. Negative 45I times 5I is a negative 225I. But remember, that I squared, but remember the I squared equals negative 1. So it's going to make that a positive 225. And y'all look, I'm going to show you again how to do that on the calculator. This I stuff we can multiply really quick. I had what? 5I, 5 second period times, what was it? Negative 45I. And that gave me 225. Remember the plus 0y. I'm going to change one thing. Let me see. I'm going to change this to my plus. I'm going to see what this does. So 5I times negative 45I equals 225. So I guess the CE always puts that 0I stuff on it. But my TI-84 Plus, probably the apps will do this. And there's that 225, okay? All right, y'all, that gives me a remainder of 0. So now I got 4 numbers left, so that'll be the 4 numbers I'm going to do with synthetic division again. Remember, you got to get this down to 3 numbers before you can do the quadratic stuff. So this is like, since that was an x4, this is like 1x cubed plus 5x squared minus 9x minus 45y. So y'all, let me ask y'all this. So y'all got to answer this one for sure. They gave me 1 0. I got 4 altogether. What is the next one y'all would try? Just to see if y'all have any ideas. Well, y'all went quiet after the break, right? All right, y'all, so let me show you. Since 5i was a 0, remember, don't that mean negative 5i must also be a 0? So, Darren, you got it perfect. Negative 5i. Because remember, i's always come in conjugate pairs. All right, y'all, so bring the 1 down. 1 times negative 5i is a negative 5i. 5i minus 5i is 0. 0 times negative 5i is 0. Negative 9 plus 0 is negative 9. And y'all, negative 9 times negative 5i is a positive 45i. Notice I don't have an I squared this time, just an I. So it don't go away like them I squareds did earlier. All right, y'all, so let's see. Negative 45 and 45 give me 0 remainder. So I know the first of the last 3 zeros is negative 5i. Now I'm going to do the quadratic stuff. I'm down to 3 numbers. So this one will start 1 degree less than this one did. So that'll be 1x squared, 0x's minus 9. And y'all offset that equal to 0. So once again, you got a 0 for the x's. So I'm going to solve this by doing square roots. So y'all add 9 to both sides. X squared equals 9. And then square root each side. So that'll be a plus or minus square root of 9. So everything comes out on this one. Square root of x squared is x. And that'll be a plus or minus square root of 9, which is 3. So for this one, the other zeros, now y'all don't put the 5i. They gave us that one. We got to put our negative 5i, 3, and negative 3. So that one you had to come up with 3 of the 4, okay? All right, y'all, one more problem to show y'all, and that'd be like number 12. All right, so on this last one, they want me to find the rational zeros. And then the other zeros of, all right, so my function is f of x equals x cubed minus 21x plus 20. Then, so that was A, would be that part. And then on B, they want me to factor into linear factors. So that just means sort of do like I did earlier, putting them in parentheses, okay? Um, so they didn't give me no zeros to start. So y'all, the easiest way to find the first zero, or even all of them, is to graph it. So I'm going to graph it to find any zeros. Because if I can get at least 1 0, I can do synthetic division and get the others, okay? So y'all, let's go to y equals and graph this little polynomial. So I'm going to go to the calculator, go to y equals. All right, so we had x to the third. So that'll be x exponent 3 minus 21x and then plus 20. All right, y'all. So what we want to look for, zeros are the same as the x-intercepts, remember? We learned that a few weeks ago. So if we can graph it and see where it's crossing the x-axis, we can find zeros. All right, y'all. So this graph goes up, down, and back up. But I'm just worried about where is it crossing that x-axis at. And y'all, I'll show you a trick. That looks like this one's crossing at what? -1, -2, -3, -4. That one looks like it's at -5. And then right here, you got two more. That looks like it's crossing at 1. And then this one looks like it's crossing at 4. So I could use any of them. So I think if I look at the table, if I go to negative, well, there's a 0 at 4. So do we know that's a x-intercept? There's a 0 at 1. So that's the x-intercept. And then I see the other one at what, -5? There's a 0 for that y value. So technically, those are my 3 zeros because I only had 3 since it's an x cubed. So y'all, let's see, what was those? So x equals -5 is one of them. And then I couldn't remember the other one was 1. So that's one of them. And then I think it was what, 4, that other one? Those were the 3 places that crossed the x-axis. So those are my 3 zeros. So it'll have A, B, and C. All 3 of these are rational zeros. So on this one, I would put there are only rational zeros. And the zeros are -5, 1, and 4. Now, sometimes, well, not on this problem. Everybody's going to get rational zeros only. But they do have a B that says the rational zeros are blank and the other zeros are blank. The other zeros would be the square root zeros and the imaginary. But y'all aren't going to get them on this problem. All y'all's are going to be rational, okay? So you're going to always choose A on that one. And then B, the factorization into linear factors is, well, y'all, all we're going to do is put these in parentheses and change the sign. Remember, the factors always have opposite signs than the zeros. So since that's -5, you'll put x plus 5. Since this is 1, you'll put x minus 1. And then since that's +4, you'll put x minus 4. So they're just wanting y'all to realize in the long run that the factors always have opposite signs than the zeros. Just like I did on the first 3, I started with -5, but my factor was an x plus 5. because I added 5 to both sides and all that fun stuff. So y'all, that's all they're wanting on this factorization into linear factors. Put them in parentheses and change those signs. Okay? Um, Now, say you was only able to, I'll show you how to get the other two. Say you only had one zero or intercept that you could find, you would come down here and do -5 and then put this in for synthetic division. So 1x cubed, 0x squared, so you've got to put a 0, -21 for the x, and then 20 for your number. So y'all, I'm just going to do this one real case, because if you were able to find one of them, this would be how you get the other two, okay? You would do the synthetic division. So bring the 1 down. 1 times -5 is -5. 0 plus -5 is -5. -5 times -5 is 25. -21 and 25 is 4. And then 4 times -5 is -20, which gives me a 0 remainder. So, remember, since this started out of x cubed, this now means 1x squared minus 5x plus 4 is my new polynomial. And y'all, I'm going to set that equal to 0. So this is the other way to find the zeros. But y'all, you got to use the graph to at least get one of these 3 numbers, okay, before you can do this. All right, y'all, so at this point, you can do the quadratic formula. 1, -5, 4. You can't do the square root on this one because you got the x in the middle. But y'all, this one will factor pretty nice. X squared is an x and an x. This last number's positive, so both of these factors will be negative like the middle. Factors of 4 that add to get 5 would be 4 and 1. And then y'all remember, set both them equal to 0. So this one, add 4. We get x equals 4, which is one that I needed. Here I would add 1 and get x equals 1. So if you have at least one of your zeros, you can find the other 2 on this problem by factoring that polynomial, okay? And you still get a 1, 4, and -5, just like this one. And this one I can tell because all these were places where it crossed the x-axis. So if you're going to graph it to find any zeros, you're trying to find x-intercepts. Okay? All right, y'all, so let me just tell you about the support real quick. On the support, the first one is a FOIL problem, just like I did earlier on foiling the 2 things times the 3. The second, third, and fourth question are giving you stuff like this. 5 plus 2i, 3 minus 7i. These can be done on the calculator. So this would be like number 2, 3, and 4. And y'all, let me show you how to do this on the calculator. So I'm going to share the calculator just to show you. So quit the graphing. And y'all, you can punch these just like they look. Parentheses, 5 plus 2, second decimal for the I, and then open parentheses, and then do 3 minus 7i, close parentheses. When you hit enter, you get 29 minus 29i. So this will FOIL those out for you on 2, 3, and 4. So you're doing this. And then on the fifth one is a problem like we did last week when we were checking to see if numbers were zeros. So on the fifth one, you're going to do synthetic division on the two numbers, and you're looking for a zero remainder. If you get a zero remainder, then it means it was a zero. Any other remainder, you put no on those, okay? So it's just another one like we did last week in 8.3, okay? So one's spoiling, 2, 3, and 4 are multiplying imaginary numbers. And then number 5 was using synthetic division to tell if a number was a zero or not. Alrighty, y'all. So let me stop my share. All right, y'all. Any questions on this? So I'll send a video out in about, it usually takes me about 30 minutes to an hour. I'll have the video sent out for you. Um, and then, like I said, the support was doing what I said, the foiling, the imaginary numbers, and then what was it, synthetic division.